Let's look at organic families or homologous series. For this course, you need to know 9 different organic families. They are the hydrocarbons and derivatives of the hydrocarbons. The hydrocarbons consisting only of hydrogens and carbons on the chain, you already know as the alkanes, alkenes, and alkynes, and they differ from each other by the amount of bonds they have between carbons in the chain. Never look at the bonds between carbons and hydrogen or any other type of element bonded to the carbon, but only what are the bonds between the carbons. If there's only single bonds between the carbons, then it's an alkane. If there's at least one double bond between carbons, then it's an alkene. And the first bond is always a sigma bond, and then any additional bond will be a pi bond. A pi bond is a weaker bond than a sigma bond. When there are 3 bonds between carbons, the first is a sigma, and the other 2 are pi bonds. So you have 2 additional pi bonds, and that, because there's an additional pi bond, it will pull the carbons closer together in an alkyne than in an alkene, right? So the derivatives of the hydrocarbons are as follows. They are the alkyl halides or the haloalkanes. They consist of a halogen as a substituted group onto the main chain bonded to any of the carbons on the chain. An alcohol is where you have a hydroxyl group. We call this a hydroxyl group as your substituent onto one of the carbons in that carbon chain. An aldehyde has a double bonded oxygen on one of the carbons, and a ketone exactly the same, but the difference between an aldehyde and a ketone is that the double bonded oxygen on that carbon is on one of the extreme carbons. So it's the carbon either at the front or right at the end of the chain. While with a ketone, the double bonded oxygen sits on a carbon that is not either the first or the last carbon on the chain. It doesn't have to sit slap bang in the middle of the chain, but at least it shouldn't sit on the first or the last carbon of the chain. Think of a key, right? And a key goes into a keyhole, right? And so this keyhole will sit sort of in the middle or not at the end of that molecule. Then we have the carboxylic acids. A carboxylic acid simply consists of a COOH functional group, or it's a double bonded oxygen onto a carbon, an extreme carbon, meaning the carbon either at the end or at the beginning of the chain. And then on that very same carbon, you have a hydroxyl group bonded to that same carbon as the double bonded oxygen. We call this the COOH group, right? It's a functional group because it makes that organic substance a carboxylic acid. Now, an ester has a double bonded oxygen onto a carbon, and on that same carbon, you have an oxygen between itself and another carbon on the other side. So this is often called an oxygen bridge between 2 carbons, and on one of those carbons involved in on the other side of the bridge, you have this double bonded oxygen. And right, so this is sometimes called a carbonyl group. Okay, so these are the 9 types: 1, 2, 3, 4, 5, 6, 7, 8, and 9, the 9 organic families that you should know.